Hello, this is my code to do the coin tossing project. So my code will have three main parts. So the first part is for finding the simulated probability. The second part is finding the predicted probability, and the last part is for finding the error, the relative error, and then print out all of them into a formatted table like this. So for I will explain every steps. So the first thing to do is define a function to flip a coin for n times, then returns the number of heads. So I will have two small functions. So the first thing to do is we import the random, and then we define the function ctph to flip a coin. The function ctph will receive the ph as the parameter, which means the probability of head occur. So this function will return 1 for head and 0 for tail. So after we will use an if command and a boolean. So after getting the result, a number of floats between 0 to 1 by using the random, which is flip, and then we will use the if command if flip smaller than ph, so which means will be the head, so the function will return 1, else it will return 0. So the next thing we will use is the result of this function returns to write a function ct and toss the parameter n and ph, which means toss the coin, which ph is the probability of head, and we toss n times, and we count the number of head. So in this function, I will use some accumulation and h to count the times that the head occur. So a for loop will be used, which means tossing the coin for n times. And for each toss, A will receive the result, which is returned by the CTPH above. So each time the head occur, A will be 1. If a tail occur, A will be 0. Then A will be added to the sum accumulation and h. So after the loop is done, we will get the total times that the head occur when we toss the coin n times, and then the function will return the number of head, which is nh. So the next thing we do is define a function to toss the coin n times, which means we have n times, and each n time we toss the coin for n times. The function will return the dictionary contains the number each combo of head, tail occurs. For more detail, so for example, if we toss the coin for 3 times, so we will have 4 combos, which means 3 head and 0 tail, 2 and 1, 1 and 2, and 0 and 3. So we will have 4 combos. So the dictionary will contain the number each combo occurs when we toss the coin n times for n times. And after that, we will find the probability of each combo of head and tail. And then finally we find the sum of all these probabilities. So the first thing we would do is we define a dictionary th. This is the command to define a dictionary. And when we toss a coin for n times, so head will occur from 0 to n times. So here I will use a for loop to create n factor in dh, and each of them are the number of hash that the head occur from 0 to n times. Then we will use a for loop to repeat tossing the coin n times, and each n time we toss the coin, so we will get the result of hash, which means the number that had occurred from the city and toss and ph function that I have defined. And then we will add 1 to the corresponding factor in dh, and then we will use a sum accumulation to calculate the probability of all these cases. So for each factor in the dictionary, this probability will equal to the number that the case that combo occur divided by n, and then we will add it on this probability to the sum accumulation. Then we will get the sum of probability. Finally, we will return the dictionary dh and the sum of all probability when we toss the coin n times. So the next thing we do is we define the function to calculate the predicted probability. So I will have 3 main steps. The first step is define the function to find the factorial of number n, and then I will define a function to calculate the quotient of n factorial of n divided by factorial of n multiplied by the factorial of the number n minus n. This expression will help us to find the predicted probability in the last function. So the last function we will use to get the predicted probability of the number of heads occurred. And so the first is the function factorial of n, and it's a parameter. And then I will use a product accumulation to equal product accumulation first is equal to 1 and a for loop to find the factorial of n. So for each number from 1 to n, we will multiply the outcome by I. Then after the loop is done, we will get the factorial, and then we return the outcome. The outcome is the factorial. And then the next function is CNN and n. This function will get the factorial of n, which is the num of n, which is denom 1, and the number n minus n, which is denom 2. And we will have 3 factorials. And then the next thing, we will find the product of the factorials of n and the number n minus n, which is denom 1 multiplied by denom 2. And then we will return the quotient of the num, which is the factorial of n divided by the denom, which is the product of the factorials of m and n minus n. Then we will define the function to get the predicted probability of the number of heads occurs. And so probability of number of heads occurs if n toss are made with a coin having probability of head equal to ph. So this function will get the inputs of n tosses, which means the number that we toss the coin, the n of the nh, which is the number of head occur, and the ph, which means the probability of head. And then we will find the probability of tail and the number of tail. So the probability of tail will be equal to 1 minus the ph, which is the probability of head, and the number of tail occur will be the number that we toss the coin minus the number that head occur. So after finding these two, so we will get the value which is equal to the result we get from this function, which is the result of this expression multiplied by the probability of head power the number of head, and multiplied by the probability of tail power the number of tails occur. And then this number we get from this expression will be the predicted probability of NH8 occur, and then we will return this predicted probability. So the last part we do is we will define the function to print to a file or a table consisting of the number of toss, the probability of head and tail, the case of the combos that head occur half time and the tail occur n minus half times. Also the simulated probability, the predicted probability, the error which is equal to simulated probability minus the predicted probability, and also the relative error which is equal to the simulated probability minus the predicted probability over the predicted probability and then multiply by 100. So the first thing to do, we will create a file by using an open command to write, and then we will use a nested loop for n, m, and ph. So we will have total 48 cases, and then we use print command and format to print out the part about the table of the probability and error. So for detail, the part will have the number of tosses, the probability of head, the probability of tail. So then we will get the dictionary DH and the sum of the simulated probability from the function that we have already defined by using the parameter n and ph for each case that the nested loop creates. Then we will use a sum accumulation to calculate the sum of predicted probability first equal to 0, and for each combo in the dictionary, the simulated, we will get the simulated probability which is equal to the value of that combo, that factor, divided by n. Also, we will get the predicted probability by using the function probability head and RHPH that we had already defined, which is the value. And then we will find the error by the error will be equal to the simulated probability minus the predicted probability. Then we will find the error, the relative error by we find the simulated probability minus the predicted probability, then we divide it by the predicted probability, and then we multiply by 100. So the next thing we will find the sum of predicted probability. So for each case, each combo in the dictionary, so we will get the predicted probability by the function probability of head, and then we will add them into the sum of predicted probability, and then we will get the sum of predicted probability at final. And then for each case, we will print out in format the number of head, number of tail, the simulated probability, the predicted probability, the error, and the relative error into the file. And then lastly, we will print out the sum of simulated probability and predicted probability in format also. And the last thing, close the file. So let's check it out. This is my code, and then I will run it. I have to wait for a while. Just only check out our result. So we will have the table of totally 48 cases. That's my coin tossing project. Thank you, teacher.